According to Section 424.3 of the National Electrical Code, motors shall be provided with overload protection in accordance with 430.32. The motor overload device shall be capable of carrying the starting current of the motor. Section 430.32 states that where a motor is manually started, the motor overload protective device shall be rated not less than 115% of the motor nameplate current rating. To determine if you can combine 3 fan terminal units, or FTUs, on 120 amps, 3-pole circuit breaker, we need to consider the applicable sections of the National Electrical Code, or NEC, and perform some calculations. The question indicates that each FTU has a 4 kilowatt heating element, or 1/3 horsepower fan motor, and operates at 277/480 volts, 3-phase power. The question also states that the FTU are currently provided with non-fused disconnect switches. First, let's determine the combined full load current, or flaw, of the 3 FTU. Since the heating elements are resistive loads, their current draw is constant and doesn't require the same considerations as the fan motors. The fan motor full load current is the primary concern for overload protection. We will focus on the combined current draw of the heating elements for sizing the circuit breaker and conductors. To calculate the combined current of the heating elements, we use the formula power equals voltage times current times the square root of 3 for 3-phase circuits. Rearranging the formula to solve for current, we have current equals power divided by voltage times the square root of 3. The combined power of the 3 4 kilowatt heating elements is 12 kilowatts. Converting kilowatts to watts, we have 12,000 watts. The voltage is 480 volts. Therefore, the current is 12,000 watts divided by 480 volts times the square root of 3, which is approximately 14.43 amps. Now, let's consider the fan motors. Each motor is 1/3 horsepower. To determine the full load current of each motor, we need to consult the NEC tables, specifically Table 430.250, which provides the full load current for 3-phase alternating current motors. A 1/3 horsepower motor operating at 460 volts, which is close enough to 480 volts for our purposes, has a full load current of approximately 0.84 amps. Since there are 3 motors, the combined full load current is 3 times 0.84 amps, which equals 2.52 amps. Therefore, the total combined full load current of the 3 FTU, including both the heating elements and the fan motors, is approximately 14.43 amps plus 2.52 amps, which equals 16.95 amps. Next, we need to determine the required overcurrent protection for the circuit. Section 430.52 of the NEC governs motor branch circuit short circuit and ground fault protection. This section allows for the use of inverse time circuit breakers, such as the 20 amps breaker being considered. The code specifies maximum overcurrent protection ratings based on the motor full load current. For motors with overload protection, the overcurrent protection device rating should not exceed 250% of the motor full load current, according to 430.52 code. However, since we are combining multiple loads, we need to consider the heating elements as well. The 20 amps breaker must be adequate to protect both the motors and the heating elements. In this case, the 20 amps breaker exceeds the minimum required overcurrent protection for the combined load of 16.95 amps, but does not exceed the maximum allowed for the motors, given the 250% rule. Now let's address the motor overload protection. As stated earlier, Section 424.3 requires that motors be provided with overload protection in accordance with 430.32. This means that each motor must have an overload device that protects it from excessive current draw that could cause overheating and damage. The provided information doesn't specify whether the FTU have individual motor overload protection devices. If the FTU do not have built-in overload protection, then individual overload relays must be installed for each motor. These overload relays should be selected based on the motor's nameplate current rating. Section 430.32a states that the overload protection shall be sized at not more than 125% of the motor's full load current rating for motors with a service factor of 1.15 or greater, or with a temperature rise of not more than 40 degrees Celsius. For motors with a service factor less than 1.15 or a temperature rise greater than 40 degrees Celsius, the overload protection shall be sized at not more than 115% of the motor's full load current rating, according to 430.32c. Assuming the motors in the FTU do not have a service factor of 1.15 or greater, or a temperature rise of not more than 40 degrees Celsius, the overload protection should be sized at not more than 115% of the motor's full load current rating. The motor's full load current is 0.84 amps. Therefore, the overload protection should be sized at not more than 0.84 amps times 1.15, which is approximately 0.97 amps. A standard overload relay size close to this value should be selected. Next, let's discuss the non-fused disconnect switch. The question notes that the FTU are provided with non-fused disconnect switches. In the past, fused disconnect switches were commonly used to provide both disconnecting means and overcurrent protection. However, the NEC no longer requires fused disconnect switches for motors that are otherwise protected by overload devices and branch circuit overcurrent protection. The non-fused disconnect switch is sufficient to serve as the required disconnecting means, provided that it is readily accessible and located within sight of the FTU, as required by Section 430.102. In summary, based on the NEC, it is permissible to combine the three FTU on a single 20 amps 3-pole circuit breaker, provided that certain conditions are met. Firstly, the combined full load current of the FTU must not exceed the ampacity of the circuit conductors. Secondly, the circuit breaker must provide adequate overcurrent protection for both the heating elements and the fan motors. Thirdly, each motor must have individual overload protection sized appropriately. Fourthly, the non-fused disconnect switch must be readily accessible and located within sight of the FTU. Here is a step-by-step breakdown of the considerations. 1. Calculate the combined full load current of the three FTU, including both the heating elements and the fan motors. 2. Ensure that the 20 amp circuit breaker is appropriately sized for the combined load and provides adequate overcurrent protection. 3. Verify that each motor has individual overload protection sized at not more than 115% of the motor's full load current rating, assuming the motors do not have a service factor of 1.15 or greater, or a temperature rise of not more than 40 degrees Celsius. 4. Ensure that the non-fused disconnect switch is readily accessible and located within sight of the FTU. Now let's delve deeper into each of these considerations. Firstly, the ampacity of the circuit conductors must be sufficient to carry the combined full load current of the three FTU. The NEC requires that the conductors be sized at not less than 125% of the continuous load, according to Section 210.19a. In this case, the heating elements are considered a continuous load because they operate for 3 hours or more at a time. The fan motors are not considered a continuous load because they do not operate continuously. Therefore, the conductors must be sized at not less than 125% of the heating element load, which is 14.43 amps. 14.43 amps times 1.25 equals 18.4 amps. The conductors must have an ampacity of at least 18.4 amps. According to Table 310.16, a 12 American wire gauge copper conductor with a temperature rating of 75 degrees Celsius has an ampacity of 25 amps, which is sufficient for this application. Secondly, the 20 amp circuit breaker must provide adequate overcurrent protection for both the heating elements and the fan motors. As discussed earlier, the circuit breaker must not exceed the maximum allowed overcurrent protection for the motors, which is 250% of the motor's full load current rating. The 20 amps breaker also must be adequate to protect the heating elements. The heating element load is 14.43 amps. The 20 amps breaker is sufficient to protect this load. Thirdly, each motor must have individual overload protection sized appropriately. As discussed earlier, the overload protection should be sized at not more than 115% of the motor's full load current rating, assuming the motors do not have a service factor of 1.15 or greater, or a temperature rise of not more than 40 degrees Celsius. This overload protection can be provided by individual overload relays or by built-in overload protection devices in the FTU. Fourthly, the non-fused disconnect switch must be readily accessible and located within sight of the FTU. This requirement ensures that the disconnect switch can be easily accessed in case of an emergency or for maintenance purposes. The disconnect switch must also be located within sight of the FTU so that the person operating the disconnect switch can verify that the equipment is de-energized before working on it. In addition to these considerations, it is important to ensure that the wiring methods and installation practices comply with all applicable requirements of the NEC. This includes using approved wiring methods, properly grounding the equipment, and ensuring that all connections are tight and secure. It is also important to consult with a qualified electrical inspector to ensure that the installation complies with all local codes and regulations. By following these guidelines, you can safely and effectively combine the 3 FTU on a single 20 amps 3-pole circuit breaker. In summary, the ability to combine 3 fan terminal units on one 20 amps 3-pole circuit breaker hinges on several NEC requirements and calculations. These include ensuring adequate conductor ampacity, appropriate overcurrent protection, individual motor overload protection, and compliance with disconnect switch placement rules. Let's revisit the core elements. First, calculating the total full load current is essential. This involves determining the current draw from both the heating elements and the fan motors. The heating element current is calculated using the formula current equals power divided by voltage times the square root of 3. The fan motor current is obtained from NEC tables based on the motor's horsepower and voltage. Second, conductor sizing is critical. Conductors must be sized at not less than 125% of the continuous load, which in this case is the heating element load. The selected conductor must have an ampacity sufficient to carry this calculated current. Third, overcurrent protection must be appropriate. The 20 amp circuit breaker must protect both the heating elements and the fan motors. It should not exceed the maximum allowed overcurrent protection for the motors, which is 250% of the motor's full load current rating. Fourth, motor overload protection is mandatory. Each motor must have individual overload protection sized at not more than 115% of the motor's full load current rating, assuming the motors do not have a service factor of 1.15 or greater, or a temperature rise of not more than 40 degrees Celsius. Fifth, the non-fused disconnect switch must be readily accessible and located within sight of the FTU, allowing for easy and safe disconnection of power. Finally, all wiring methods and installation practices must comply with the NEC and local regulations. Proper grounding and secure connections are essential for safety and reliability. By carefully considering these factors and adhering to the NEC guidelines, you can determine whether it is safe and code compliant to combine the 3 FTU on a single 20 amps 3-pole circuit breaker. Remember to consult with a qualified electrical inspector to ensure that the installation meets all applicable requirements. This analysis provides a comprehensive understanding of the NEC requirements and calculations involved in combining multiple fan terminal units on a single circuit breaker. Adhering to these guidelines ensures a safe and code-compliant electrical installation.